Hey, welcome back. We have just listened to Martin's big talk about graphical fun with WebGL shaders, and now our next will be about micro-frontend, and this talk will be introduced by Oleksandr Khivrych. He is a senior software engineer at Beamery. He has more than 9 years of experience in engineering. He's primarily focused on full stack web development and building DevOps infrastructure for his services and front end applications, and over the last 4 years has focused on implementing a micro-frontend concept in many organizations. So please welcome our new talk and have fun.
Hi everyone, my name is Oleksandr. I'm really excited to be here on this event today. And I would like to say thank you for all organizers of JavaScript Framework Fwdays Europe for having me today. I'm going to talk about micro-frontends and model federation. Before we jump to the exact topic, let me introduce myself. My name is Oleksandr. I'm a senior front-end engineer at Beamery. Beamery is the fastest growing startup in the UK and one of the leading talent lifecycle management systems in the world. I have more than 8 years of experience in engineering, working with the different technologies, as well in the backend and front-end as well. Over the last 4 years, I was focusing on enabling micro-frontend concept in many organizations. That's why I decided to share my experience and knowledge with you. So let's get started. Let's talk about micro-frontend overview. What is exactly micro-frontend? Micro-frontend is this architecture design approach in which front-end app split by the smaller semi-dependent micro applications. So the same like with microservices. You can split your web application by many services. Each service might be some small component, some road, whatever you decide on how to split your application by the micro applications. And yeah, like I said, it's Wiggly inspired and named by the microservices. And such a concept can provide many benefits for organizations. Independent development. Teams are more focused on the subject areas and clear area responsibility. So yeah, instead of developing the whole monolith, you can just own only the small part of application and be more independent. Independent deployment allows teams to be more autonomous. So yeah, exactly the same like with microservices. You can deploy your individual chunk to the environment and not depends on any other teams, which will bring significant value for the delivery life cycle. And like I said, shorter delivery life cycles and incremental upgrades, which means that when you work with the smaller parts of applications, your build will be faster, tests will be faster, and it will be much easier to add new functionality and do bug fix, and for sure deploy them independently. Such an approach reduces complexity. Separate paths are less to understand than a large complex monolith. And for sure onboarding process will be much faster. Instead of your new employee will start to understand the whole monolith with thousands and thousands of code, it's much easier to just understand the smaller parts, and maybe in 1 week this person can start deliver some value and implementing some features. Isolating errors is another important benefit, and it might be easier to isolate errors in specific parts of the application while the rest of the app is running. So for example, you have some profile page and the user triggers some error at runtime and sees some error boundary, but the rest of the application is still working properly. He can navigate to the other parts, which is provide a really nice value because it will not crash whole the application and will show this error boundary in specific part. And here we see the another benefit is a more granular monitoring and alerting. So imagine in this profile application, we can immediately see some alerting in the Slack channel, in the Sentry, and specific team that owns this part of application can roll back the changes easily because we have this independent deployment, or make a hotfix, which is amazing benefits. But the one thing that I would like to pay your attention on is that microservices and micro-frontends, they are not completely the same. In development, they are very similar. Different repositories or modules in the monorepository. Quite similar CI/CD process, different teams. But at runtime, they are not similar at all. Because your web micro applications running in the same browser instance. That means that you will have general event loop, shared document object model with events, general address bar, and many more things from the web API. But backend services running on the separate process and instance. So we need to accept that you can't have completely independent micro-frontends. They will be semi-independent and running loosely together. But even with such a level of independence, you can achieve many benefits. You just need to accept it. That at runtime, it should act like a monolith. But sometimes developers going further and trying to completely isolate micro-frontends. And it might be poor architected, and because of the limitation of technologies, a lot of risk for organizations. Let me share with you 5 common mistakes while architecting micro-frontends. So the first one is poor code sharing methods. It's when you don't have any lazy load logic, and each time you load the whole bundle chunks for your micro-frontend, which lead to the bad build and web performance. The second one is when you divide our micro-frontends too fondly, and it's difficult to track our shared components, harder to update and test and deploy your components individually. For instance, you can have one micro application for the profile page, but instead of it, you create 5 unnecessary micro-frontends, and right now there are huge dependencies between all of them, and it's difficult to deliver new features and do bug fixes, so it's a huge risk for organization. The third one is overcomplicated communication between micro-frontends. It's when you do event bus, for instance, with hundreds of events and event listeners, and it's difficult to support, and you need to have really good documentation instead of just use props API if you're using React and contest bus API. The fourth one is problem with global libraries. It's when you don't have any logic for shared dependencies, and each time you load the same libraries and you have duplicated dependencies at runtime, and you don't have any logic of updating them correctly, and have only few versions of the library at runtime instead of the 5 or 6. And the last one is multi-framework support. It's when you have support for the Angular-based micro-frontends, React-based micro-frontends, Vue, etc. And it's actually higher risk for organization because they need to find developers who can work with all of the frameworks and libraries. And also it's a bad web performance because you have many libraries at runtime, they're doing exactly the same. The only one reason to do it is when you're migrating from the legacy, for example, Angular application to the React one. It does make sense, but in all other cases, it's a huge risk for organizations. But the question is there an existing solution followed by the industry that we can use to avoid such a risk and have enough benefits? And I found some. It's not exactly micro-frontend concept, but it's a modern monolith in Monorepository. So we can use tools such as NX or Turborepo to scaffold your project with any framework and library that you want to use, like Angular or React. And in the end, you will have single React app if you choose React with the single React DOM tree, with a good web performance, because it's a still monolith, you don't have any duplicated dependencies. You can use React Lazy, for instance, for the lazy load. Independent development, which is really important, that we need for our teams to own separate models. So if we have many modules in one repository, we can work separately in the different modules. And the low level complexity as well. and custom child libraries. So you can create custom libraries in your Mono repository and avoid code duplication, have more collaborative team, which is amazing benefits actually. And we don't have such a bad risk and problems that I showed you previously. And the thing is, maybe it's enough for your organization. Maybe you don't need to go further. Maybe you don't need the micro-frontends at all. But when you realize at some point that you need to improve your application, that your teams need to be more isolated, more independent, and software delivery cycle should be much faster, you might think to improve such a problems like it's still monolith. You don't have independent builds, you don't have independent deployment, and some solution for upgrading global dependencies. Can we do it better? Can we have super fast monolith at runtime with distributed decoupled frontends for the development and delivery? And the answer is yes, we can do it better with Modular Federation plugin. It's the killer feature in Webpack 5, which allows you to load modulars at runtime from another Webpack project. And it's exactly what we need. Let's take a look on this diagram. Regarding Modular Federation terminology, each Webpack project, Webpack assembly, Webpack build, it's a separate container. Container can be remote or host. Remote means that container exposes some modulars for reuse for other containers. Host means that container consumes some modulars from another containers. But actually container can be the host and remote simultaneously. For example, container can expose few modulars and also consume few modules from another container. And also container, which is the entry point of our website, is called application. And I want to mention that, like I said, inside the container we have many separate builds which lead to the good build performance. Everything load lazy at runtime. Exactly what we need. I would like to pay your attention on this diagram. There are two aspects that I would like to show you. It's expose modulars and shared modulars. So when container want to load some modulars from another container, it's do this round trip. So it's container, first of all, go to the shared scope and check, okay, is this module already loaded? Maybe I can get it from shared scope. And in this case, if it's something in shared scope, it will just use it and it will prevent to do any additional request to the CDN. Then, if not, it will go to the container references, which will provide these modulars like a separate chunks, and then put it to the shared scope with specific version. And then container will use it. So for example, you have some component, I don't know, like profile rolled, that need to be rendered in some main application. And this main application container will just go and request it, check shared scope. If no, in the shared scope, it will go to the profile container references, and then profile container will put it to the, provide the modulars and put it with the version to the shared scope. And when it try to load it again, when you return to this route, for instance, it will not do any additional request to the CDN, it just will load it from the shared scope. The same logic with the shared modulars, shared libraries. So when you build your Webpack application, it will see all libraries that you're using inside your application, like React and any other libraries. You can mark them like a shared dependencies, and then it will do the same logic. When you load some shared dependencies like React, for example, it will go to the shared scope, check it is something in shared scope. If not, go to the container references, maybe itself, like the same container references, and then do the same logic. Provide React.js chunk, put it with the version to the shared scope, and then you can use it. So such an approach provides really good web and build performance. And also this version check is really important because it provides more flexible way to update your global shared libraries as well. Moreover, Modular Federation has a huge community and followed by the industry. And Many companies use Modular Federation, such as Netflix, Microsoft, Amazon, Reddit, and many more big names. And it's really important when you choose technology for implementing micro-frontends to have a good community. And this is the way they can use to implement modern micro-frontends, just using such a tool to avoid unnecessary risk and problems and have a good build performance and web performance as well. Let's take a look on the Federated React application that I'm going to demo you in a few minutes. Let's say this Federated React application divided into 3 micro applications, which is actually 3 different Webpack projects in one repository. So the first one, which is our entry point to the website, is a shell application, shell container, which handles all global logic such as routing and layout logic. The second one is an order container, which expose 2 different models. First one is an order service, which just render the page of the with the order list. And the second one is a recent order widget that you can reuse in other containers to show recent orders. The third application, micro application, it's a dashboard, which basically exposes just a dashboard page. As you can see on this diagram, each micro application owned by the different teams. Team A owned shell application, Team B owns order application, and Team C owns dashboard application, dashboard container. Moreover, you can see on this image that we have global dependencies, and only one instance of such a global dependencies that are used across all of the applications is automatically handled by Webpack Modular Federation and loaded at runtime. And as you can see, to load one of the model, I just use ECMAScript sync model import or async import for the lazy load. Okay, and right now I'm going to do live demo and show you this Federated React application. So let's take a look on my screen and VS Code. As you can see here, I have shared routing mono repository with 3 modules. First one is dashboard, order, and shell, exactly that we was talking before. So the important thing that each of my model micro applications have Webpack config with all needed logic to build my application actually. But the important part is each of the Webpack config has Modular Federation plugin. And in this Modular Federation plugin, I specify a specific config with name of my container, my micro application. In this case, it's shell. Also, I specify file name of my manifest. So it's something internal in Modular Federation. Each time when you want to reuse some modules from another container, first of all, you need to load or preload remote entry, which is manifest for the federated applications. And by default, I name it remote entry.js. The most important part here is a remote config. So also I need to specify which kind of containers I want to load module from. And in this case, I would like to load module from the order, dashboard, and shell itself. And as you can see, I specify scope and then URL to the remote entry, to the manifest of each container. And each container running on a different host, 4002 and 4001. Moreover, right now I hardcode this URL during the build time, but you can easily use promise new promise feature in Webpack 5 to load it at runtime, to specify this URL at runtime, because on your environment it might be some CDN. But for the live demo, it's absolutely fine to show you the concept. And then let's go to the another webpack config, which is in the orders page. The same config that needed to build our application, micro application, but a different name in the Model Federation plugin. It's order right now, the same name of the manifest, and then remotes. And in the remotes, I need to load some global modulars from the shell. For example, reuse some context API from the shell. Moreover, I expose few modulars that will be used by the shell. It's recent order widget. I specify the name of the model and the path to this model, and order service. The same. I specify name of the model and the path to the exact directory. So here, as you can see, I specify srt/order service, which is in my source directory, and the same for the recent order widget. So order service is a page, separate page with list of the orders, and the recent order widget is just a small widget you can render on the any other places that show list of the recent order widget. And let's take a look on this component. So yeah, so order service is just a table which render page with list of the orders, and the recent orders widget is just a smaller table, just a separate component that render the smaller table of the recent order widget. And finally, let's go to dashboard. So in dashboard we actually have the same config, but in the Model Federation plugin is different. Again, different name, the same manifest name, remote. So in this case, I consume modules from the order and the shell as well, and expose modulars. Only one module that I expose is dashboard service, which is dashboard page eventually, which render currently some grid with recent order widget from the orders. So as you can see, I use just React Lazy and the async import to load some model from another container. And here I use, first of all, first pass is the name of the scope, name of my container, it's order, then name of the model that I would like to import, recent order widget. And that's all. Just render it using the React Lazy. And it's pretty familiar. It's nothing different from the way that you do in the Monolith application. The same sync and async import. But you need to keep in mind that the first part should be name of the scope. The second one, name of the model. Or name of the container and name of the model. Let's go also to the shell. Shell entry point file, and here we see that shell has some logic here to draw basic layout and have, using React router, draw two rows, orders and dashboard. And the same, it's using the lazy import here to load some models from the different containers, different micro applications, and name of the model as well. Then the thing I would like to show you, for example, that the orders page use just a regular sync import to get some required function from the shell service. And all this import automatically handled by Model Federation at the hood. And this works. Just use this function and during the render, and this works like usual. So the same import like you use in the Monolith application. Another concept that I would like to pay your attention on is another property inside Model Federation plugin, which called shared. So in the shared property, you can specify your shared libraries. In my case, it's React, React DOM, and Material UI Core. And I specify a specific version of this library and singleton, true. Because I want to load this library only once at runtime, which is necessary for me to have good performance. Moreover, because React is something that can be duplicated, it should be only one version of React, it definitely need to be a singleton. The same with React DOM. The same with Material UI because of the context API. But also you can add here any libraries from the package JSON. Usually you can just put all libraries here from package JSON, specify that it's a singleton, and specify required version. There are many other properties here, like a fallback API. If it was some error to loading such a library, it can use some fallback version, and many more options. But usually I use only singleton and required version. For example, if you said that you want to load material UI only once at runtime, but it should be some specific version compatible with, it will also do the version check that I was showing you previously on the diagram. And let's take a look on the live demo example. So let's refresh our page. As you can see on this page, we have application running on the port 4000, which is port of our shell application running on. And /dashboard is our default route where application shell wrote us. So the application shell actually handle all this logic layout and routing. So basically all of this stuff is part of the layout, and this page is a dashboard page from another application. And inside dashboard page you have recent orders widget from another application, micro application. But at the runtime, as you can see, it's the single React DOM tree, exactly that we was talking about, with a good web performance and build performance as well. So like we said, we want to have decoupled micro-frontends during the software delivery cycle, but at runtime it should work like a monolith, super fast. So let's take a look on the network tab. When we refresh our page, we see that initial request is to the shell to have needed entry point. Then we have remote entry JS, all needed remote entry for the rest of the application. It's kind of preload them. Then we loading our global libraries, our material libraries, and other libraries such as React and React DOM, which loading only once at runtime, and then go to the shell scope. Then we load dashboard service from the different port where our dashboard micro application running on. On the environment it will be different CDN domain, different CDN path. And then we load from dashboard, we load all needed other modules, which is a recent order widget that we render here. And as you can see, when I go to the orders page, only one chunk loaded from the different port, different URL, where my orders micro application, my container running on. And I only load this chunk, all other chunks loaded from the shell scope. I don't need to load them again. And when I go back, no other additional request needed, because everything cached and everything in the shell scope, which is really good web performance. And such a federated approach works perfect on the client side. But what about server-side rendering? And if we're talking about server-side rendering, we definitely should mention the most popular framework, React.js framework Next.js with server-side support. And Monolith Federation team created MF plugin, Next.js MF plugin, which works perfect on the client and server side, but it's actually a private one and available only via private paid subscription. But recently they announced that, okay guys, we're going to release all of our work related to the server side and Next.js to open source that you can reuse. And currently it's in beta. It still not implemented server-side support, but they are working on it. And I'm really excited to see what will be in the future and when it will be stable version, stable open source version. However, I had a chance to access to this private plugin, and I would like to show you a quick demo of it. So, the same like with the client-side Monolith Federation plugin, we have separate monorepository, Next.js SSR. And each project, each micro application in this Mono repository, it's a Next.js based application which has Next.js config. And the same, like I showed you previously with the client side example, you need to import a Next.js plugin, modification plugin, but it's actually for Next.js. Then you should specify in the config name of application, file name to the remote entry to your manifest, and for sure what kind of model you would like to expose. The same for the other project like checkout. You need to do the same. For example, checkout expose title that you can reuse on other micro applications, and checkout page. And the same with the shop application, Next.js config that expose shop page. But also home application use remotes from the shop and checkout, our usual remote config. And like we know, this URL may be set up at runtime as well. And let's go to the browser and let's refresh the page. As you can see, my home page running on the port 3000, and on initial load we can see that all needed data are rendered in the HTML. But actually this came from checkout page, which is running on a different port, and it's cool. So the initial render worked perfect, but then you need to load all needed remote entries, all needed global dependencies and chunks to be able to hydrate this page. And then when you navigate, for example, to the shop page, as you can see, our usual model federation logic works pretty well on the client-side rendering. And load shop chunk. And when you go back, nothing loaded because it's already in the shared scope. Go back to the shop page, as you can see, nothing loaded, everything perfect. But when we update the shop page, the same logic applied. So as you can see, that shop page is pre-rendered on the server, and then we load all needed chunks and be able to hydrate our page. And when you go to the checkout page, everything works perfect, and you're even able to fetch only the data from the server side, because we have this get initial props function. But for sure we can use get server side props as well. But when we update the page, you can see that our page pre-rendered. So this logic works nice. So the same like on the client side rendering is on the Node.js side, it load all needed chunks to be able to build this page. I'm not really excited about this approach, and we'll see what will be the future of this Next.js plugin and when it will be stable and available in the open source community. And that's all, guys. Thank you for your attention, and moreover, you can subscribe to my Twitter and visit my personal website where I sometimes post stories about engineering, soft skills, and micro-frontends as well. And I will jump to the Discord channel to answer all of your questions shortly. Thank you.
Hi, Oleksandr. Thank you for your talk. It was really amazing. Can you hear me?
Yeah, I can hear you. Thank you.
How is it going?
Yeah, it's fine. It's fine. Absolutely fine. I'm really excited to be on this event. Moreover, I would like to say thank you for everyone who was part of this event, like from program committee and organizers as well. I think it might be a bit complicated because it might be more intermediate level as well. But I think it's really useful for community to explore such a tool like a model federation and talk about micro-frontend approach as well.
Yeah, your talk was pretty interesting for our audience, and we have a couple of questions. First one is, what level of knowledge do I need to start learning micro-frontend? Thanks.
I think you just need to understand the concept. There is no exact pattern how to do it right. First of all, you need to understand what is better for your organization. Try to do your own research. Try to understand the concept, how you can decouple the your web application. I mean, eventually you need to know how to build monolith application initially, like how to work with React or some other library or framework, have enough knowledge with JavaScript, CSS, and all other related web tools. Then when you see like you're excited about this micro-frontend topic, you can jump to it and understand the risk, like I said, risk and benefits, and make your private research. Moreover, I know I can, when I jump to Discord channel, I will send some useful links, few books about it, or the guys who really made a lot of contribution to this topic as well.
So could you explain in general the difference between Angular application with lazy loading module architecture and Monolith application separated on different parts?
I think Modular, I think maybe I didn't get this question right, but yeah, Angular application is just, Angular initially is a framework, right? And you just use it to build a monolith application, and you can use lazy load as well. But all the time when you build your application, you build the whole, all the chunks of your application like a monolith, right? And you deliver only one chunk of application. But when you split your application to the federated modules, for instance, that I was showing you previously, you can build them independently. You can deploy them independently as well. You have some version, you can deploy this artifact to the environment, but at runtime they will act like a monolith and do all of this logic under the hood using the model federation. So model federation will handle all the import on the page. Yeah, but again, I will join this Discord workspace and we can talk about it a bit more.
One more question. What troubleshooting can arise using module federation plugin?
Do you mean, sorry, can you repeat again? Like what troubleshooting tools
Troubleshooting means, yeah, when use module federation in Webpack, as in your example, maybe you struggle with some issues or you got
Yes,
like
I
a
got it.
troubleshoot. Okay.
Yes, I got it. So I didn't have a lot of issues with it. The only one problem was, for example, when you're using the cache headers to cache your public static chunks on the server, and then you deploy such independent chunks to the environment, and we're using some version, like semantic version, to understand which version of the specific environment. But the problem is all shared modules initially inside each of the micro application. For sure, if you have a core application, it might download most modules from the core. But anyway, we have this unique version, which means that each time when we deploy some micro application with global dependencies, it will invalidate the cache version. It will invalidate the cache version, even if we didn't change any global dependencies. So in this case, you need to have like each path per environment, and just, I would say, copy this version to this environment with all the modules to prevent this unique Y version to be able to not invalidate the cache unnecessary. So there was only one issue. And in general, another issue is caching errors. For example, if some module was loaded unsuccessfully, you need to have a kind of try-catch logic under the hood using the model federation plugin API and cache this error. And instead of like crash the app, you just show the error an error on the screen. And in general, guys, model federation is just a tool. It's Boolean tested, and the most important thing is on how to use it. It's not provide any architecture for you. It's not provide any approach how to build CI/CD process. So you choose how to build correctly infrastructure, CI/CD, your processes using the Tran-based development or GitLab, whatever you choose. But model federation just unlock this micro-frontend to be able to have a good and web performance. Yeah. So this is an answer, but let's jump to the Discord channel. We can talk more about it.
Okay, you are just so hurried to jump into the...
No, it's fine. If you have any other questions, I can answer. No problem.
Yeah, just Maybe we have like a track of time. Oh no, we are just like finishing our question session. Thank you, Sasha, for your talk. It was pretty amazing. Let's join to the voice channel in our Discord. And now we have a break, and after which we meet at the talk Concurrent React 18. I might do it later by Mykola Yenin. Thank you for your talk, Sasha.
Thank you. Bye.
See ya.